Hey Lions, today I'm going to go over reviewing multiplication and how to do the algorithm and how to check your work by using the area model or partial product. Remember, you have to choose one to make sure that your algorithm is correct. Okay, so I'll use this problem. Lucy Dynamic went to the secret moon tower in order to find the priceless moon pearl. She brought 13 different helpful gadgets along with her, just like she does on all of her adventures. How many gadgets does she bring on 444 missions? Okay, well, I know that for every mission, she brings 13 gadgets. So my problem is going to be for 444 missions, she will bring 13 gadgets. So I set up my map problem, and I love using graph paper when I'm doing multiplication because it lines up everything so nicely. Okay, so the algorithm is Autique, so I'll show you the algorithm first. Remember, there are 3 steps to the algorithm. First, you take the 2-digit number and take the 1's value and multiply it by the 3 digits. And then you take the 10's value and multiply it by the 3 digits. And then you add those 2 up and you'll get your product. Those are the 3 steps. So step 1, here we go. 4 times 3 is 12. I'll put 10 here and I'll put the 2 here for 12. And then 3 times 40 is 120. I'll put the 20 here and regroup the 100. And then 3 times 400 is 1200, plus 1 more 100 is 1300. So I'll put the 1300 here. Step 1, done. Now step 2, we multiply the 10s by all 3 digits. So 10 times 4 is 40, and since I'm starting at the 10s, I can write the whole 40 out. And then 10 times 40 is 400. I can put it in the 400 column. And then 10 times 400 is 4,000. I can put it in a thousands column. Step 2, done. Step 3 says we add. So we add them together. The 1's column is a 2. The 10's column, there's 60. The 100's column, there's 700. And the thousands column, there's 5,000. So I think my answer is 5,762. I can check my work by doing the area model. I know most of us are familiar with the area model because we did it in 4th grade. And what the area model does is takes the 444 and breaks it into expanded form. So 400 plus 40 plus 4. And that would be my width. And then I'm going to take my length to be the 2-digit number, which is 13, 10 plus 3. Then I'll draw a box for the area. And then the way it works is you multiply the 10 by each of the 3 values, and then the 3 by each of the 3 values. So 10 times 400, remember our secret? You just multiply the front end. 1 times 4 is 4, and then add your zeros, 1, 2, 3, and you get 4,000. Really simple. Same thing here. 10 times 40, 1 times 4 is 4, with 2 zeros is 400. And then same thing here. 10 times 4 is 40. I already know that. I don't have to do the zero trick. Okay, and now 3 times 400, 3 times 4 is 12, with 2 zeros, so it's 1,200. 3 times 40 is 3 times 4 is 12, with 1 0, so it's 120. And then 3 times 4 is 12. Then all I have to do now is add up my numbers. 4,000 plus 400 plus 40 is 4,440. And then 1,200 plus 120 plus 12 is 1,322. And then I add them together, and hopefully I get the product that I got from my algorithm, 260, 700, 5,000. Amazing. There it is. Same product. You can also try with my favorite, and you all know this is my favorite, the partial product. And again, with graph paper, it lines up very well. So it's 444 times 13, and just like the area model, you write in expanded form, 400 plus 40 plus 4 times 10 plus 3. And then you multiply the ones by each of the numbers and then the tens by each of the digits. So 3 times 4 is 12, and I will put a 1 in the tens place, a 2 in the ones place, and off to the side I'll write 3 times 4, so I know what it is. And then 3 times 40 is 120, 100, 2 tens, 0 ones, 3 times 40. And then 3 times 400 is 1200, 1000, 200, 0 tens, 0 ones, and it's 3 times 400. Have to do the same thing with the tens. 10 times 4 is 40, 4 in the tens place, 0 in the ones, 10 times 4. 10 times 40 is 400, 400, 10 times 40, and finally 10 times 400 is 4,000, 10 times 400. Now this is why I really like the graph paper, because it lines up everything so easily. I can look in the ones column and see there's nothing there but a 2. In the tens column, there's a 10, a 20, and a 40, and that's 70. 10, 20, 40, that's 70. Yes. And in the hundreds, there's 400, 600, 700. And in the thousands, I have 4,000, 5,000. There's a problem. My tens do not match. So now I need to go back and see, because it matched here and here, but it didn't match here. So I'm going to check this one again to make sure. 3 times 4 is 12. 3 times 40 is 120. And 3 times 400 is 1,200. 4 times 10 is 40. 10 times 40 is 400. And 10 times 400 is 4,000. So when I add it again, I still get 5,772. Maybe I should go back and check the rest of my math. Oh my. Let's see. We'll try this one again. 4 times 3 is 12. Regroup my 10, and here's the 2. 4 times, there it is. 40 times 3 is 120, plus 10 more is 130. So I should have put the 3 in, and that's where my mistake is. So now when I added, the 30 plus 40 is 70. And now these match, but these don't match. So I can go back and check this one again. Let's see. 400 times 10 is 4,000. 40 times 10 is 400. 4 times 10 is 40. 3 times 400 is 1,200. 3 times 40 is 120. And 3 times 4 is 12. Now, check my addition. 1,200 plus 120 is 1,320. Plus 12 is 1,332. And caught my error here, and so 40 plus 30 is 70, not 60. And voila, this is why we have 3 different ways to check our work. Just in case we make a mistake, we can go back and find our errors. It's very important because our TEK is an algorithm. And because math is an exact science, we want to make sure that this algorithm is correct. The only way we can correct is going by and trying different other ways to solve it. Okay, so today for homework, you have a sheet of graph paper. I'm going to give you the problem is, since the front gate of Moon Tower is always locked, Lucy had to find a different way in. She saw an open window on the second floor and decided to use her grappling hook to get there. Once the hook was set, she had to climb. With each step of the climb, she moved 261 centimeters. It took her 18 steps to reach the window. How far off the ground was the window? Well, that map problem means that for every step she took, she went, for every step she took, she went 261 centimeters. So we would have to take the 261 centimeters and multiply it by the 18 steps. So this is your map problem. I want you to do the algorithm. And I want you to choose either the area model or partial product to solve that problem and to check your work. And then be ready to discuss it in class tomorrow. Thank you.